guys, hope you're doing great. Today's question is the longest increasing subsequence question, a very famous one and has been personally asked to me in a lot of interviews. So the question says, given an unsorted array of integers, find the length of longest increasing subsequence. So in questions like these, you could be asked subsequence, or it could be like a subset, or um, you know, or it could be like a sub array, right? So it's very important to understand what they mean individually. Um, so subset is like, it could be each array could have multiple subsets, like for example, 10, um, 10, 9, 9, 2, 5, 3, all these could be subsets of the given example. Um, The other thing is subarray, right? So subarray would be again some of the elements from this array, but in a contiguous subsequence manner, right? So it can be like 2, 5, 3, 7, but it cannot be 2, 3, 101. So the sequence does not need to be broken when you're talking about a subarray. And in subsequence, the order in which the elements appear in the array has to be the same, but it could be any of the integers, right? So for example, in this case, as you can see, the answer is 2, 3, 7, 101. The 5 is not there, but that's okay because it's a subsequence. So for any other questions that you solve, it's really important to understand what the question says. Is it a subsequence or a subarray or a subset? Okay. So just as we discussed, it needs the longest increasing subsequence. So for example, here 10, 9, 2, 5, 3, 7, 101 and 18. If you see, so 2, 5, 7, 101, this could also have been an answer. But the answer that I've shown is 2, 3, 7, 101. We have other subsequences as well. For example, just 3, 701, but that is not the longest, so we need to return the longest subsequence here. All right, so the question also says that there may be more than one LIS combinations, as we just saw. It is only necessary for you to return the length. So we are not bothered about what exactly are the elements in the answer, just the length. The algorithm should run in O of n square complexity. So in this video, we'll be targeting to get a solution with the O of n square complexity. All right, so these are the various approaches that we have figured out till now. Please pause the video, think about it, and come back. Okay, so I think none of these perfectly fit into what we need. And as we know, whenever there is such a happening, the dynamic programming approach is the answer. So dynamic programming is when you have to perform a particular task multiple number of times on the same set or on subsets of that problem and reuse those solutions, right? Or reuse those values to derive the final answer, right? So for example, here we essentially need to find that starting from 10, what is the longest increasing subsequence till 10? What is the longest one till 9, 2, 5, and so on till 18, right? If we just try to do that for each element, right? And since it's not a sub-array, we would have to think of all the various possible combinations, and it would be a very complex solution and a very time-consuming solution, right? So here we can easily reuse the results that we derive, for example, for 10 in deriving the results for 9, because 10 comes before 9 in the array, and so on for all the elements. So this kind of fits into the logic of dynamic programming, and the idea behind solving this would be that we would we would basically take another array, right, wherein we will store the length of the increasing subsequence till that particular element. It would be the same length as the given array nums, and then we would reuse those values to find the longest increasing subsequence for the next elements. So as we implement, it would get better and clearer. So let's start. Okay, so first of all, let's think of any base cases that we might need to consider. Cool. So if there is just one element or there is no element in nums, then the length of nums should be the answer, right? Because that is the longest increasing subsequence. So we'll just say that if nums dot length is less than or equal to 1, right? Then just return the length, whatever it is. Cool. Okay, now as I was saying, we just need to create another array. We'll just call it DP for dynamic programming for this purpose. And the length would be the same as nums. Sorry. Okay. Fine. And there is a method called arrays.fill, which populates all the elements of the array with a given value, whatever we assign. So we'll just make it 1. Reason, because every element is a subsequence in itself, and the minimum length of an increasing subsequence for every element would be 1. That is the element itself. That's why we fill it up with 1. Okay. Now let's just start traversing our array. Equals 0, I less than nums dot length I plus plus. Okay. All right. So I guess we need to start from 1, because there has to be some element before that which value we can use, right? So for the 0 index element, there's nothing before it, and that's why we don't need to do anything, because still there 1 is the answer, right, which we have already assigned to that index in DP. So we'll just start from 1, and we'll take another loop, okay, called J, which will start from 0 always, because we want to cover all the elements before this element, right? So, and J would be less than I, and J plus plus. Okay. Right. Now, we need to check that if the value at J is less than my value at I, because only then it can be an increasing subsequence. If it is more, then we don't even want to look at anything else apart from that. So what we'll do is that if nums of J, right, is less than nums of I, okay, then we want to consider. So then we just check that the dp of I should be equal to, now there is a possibility that using some other combination from some other element before this, there is a longer subsequence that can be formed. Okay, so we don't want to miss on that, and we don't want to override that result which we might have calculated already, and that is why we just take the max. Okay, so math.max of whatever dp of I already has, right, using maybe other elements before this, or dp of j plus 1. Now why the plus 1? Because this is a new sequence wherein I will add up, and dp of I should have the length of the longest increasing subsequence till I, right, including I. So if we are updating this, then it should include this element itself, right? So that's why we are adding a 1 here. Okay, looks good. So yeah, now we also have to find the max. So instead of like going over the DP array altogether, again, what we'll do is we'll just take max, initialize it with some value -1, and after finding out for every I, whatever is the longest increasing subsequence till I, we'll just, update max, right? So again, the same thing, max, comma, DP of I. Okay. And so we can just simply return max. Okay. Let's see if it works. Okay, let's submit it. Cool. So it works, right? So the time complexity for this is O of n square, and the space complexity is O of n because we're using another DP array to store the length of increasing subsequences till that particular index. So I hope you get a lot of help from this on dynamic programming, and if you have really liked this, please like, share and subscribe. Keep coding and take care, guys. Bye bye.